Thank you.
Okay, so you have started recording, and also I'm sharing the screen now. Yeah. Okay, so now I'm probably I'll do maybe 2 or 3 questions today. So I have started with question 3. So in question 3, there are 7 water samples. You can see here. Is that right? Can you see it?
Yes, sir, we can see.
7 water samples. I am putting a green color there. So so we can find how many data points. Count is 7. We can use the equation count. So we can say like how many count is, because n is needed, because that will depend the degree of freedom. So we need the count. So to find the count, we can say count count. So what I'll do, I'll always put the command here, that count, and then you range of the data, which is our B3 to B9. Okay, and then I'll write the equation here so that you can see the equation there. So count, and then I can select the range here. So count is 7, and of course we will require the mean. So I'll take the average. So average is really, our equation is a VERAGE average of B3 to B9. So we can write here average, a VERAGE average of our this screen. So that we got the average, we got the count, and we need the standard deviation as well. Standard deviation, which is, we know standard deviation equation STDV, and our range is B3 to B9. We call STDV, standard deviation of B3 to B9. So we got the standard deviation, and what would be our degree of freedom? Degree of freedom is, equation is n minus 1. So that means that our degree of freedom is 7 minus 1. That's L minus 1. So degree of freedom is 6. So I'll put a kind of border here so that it will be easy to understand, easy to see for you. And then I'll make this one bigger here. Okay, so that's the degree of freedom we got. And we want to estimate the standard error. So standard error is estimated by standard deviation divided by square root of n, because we are dealing with a sample. The standard error is standard deviation STD dV, standard deviation divided by square root of data points, how many data points are there. So that means my standard error would be, standard deviation is this cell here, divided by SQRT of n. N is our 7, counts that cell. So our standard error is 0.1069 and so on. So that is our standard error. And what is our level of significance? Find the 95% confidence interval. So 95% confidence interval means our alpha is, so our alpha, or same level of significance, also we call it significance level. Significance level. Significance level is If it is 95% confidence interval, then it is really 1 minus alpha. Which is 1 minus. So alpha in this case is 95%. So 0.95. So basically I'll put another here, 1 minus 0.95. So basically here 1 minus 0.95. So I have. So it should be a fully like.
Comma, sir. Here it will be points.
Yeah. So,
so where'd you get 0.95?
95, you know, is the question is asking that find the 95% confidence interval. So 95%
is
basically is 0.95. Okay. Is that clear?
Yes, sir. Thank you.
Okay. So we got the significance level there. And basically, in this case, we have to use a 2, like it's, we have to use alpha by 2 because we are trying to find out both lower limit and upper limit there when you want to find out the significance interval. So we have to find out our alpha by 2, alpha by 2. Which is 0.05 divided by 2. So that means that this is divided by 2. So that is our alpha by 2 value there. So now we want to find out the t distribution because the confidence interval is we have to find out the t distribution value at alpha by 2. So we need to find out t and alpha by 2 that we have to find. So in finding that, the equation we'll be using is t dot inv, and then we have to write our that alpha value, that 0.025, and we have to write our degree of freedom. So that is our or I can write it alpha by 2 here probably, which will be better. Alpha by 2. And then we have to write out degree of freedom here. Okay. So then I will again write another line, t dot inv, and alpha by 2 is our 0.025, and our degree of freedom is how much? What is the degree of freedom here?
6.
6, n minus 1. So I'll make it a little bit bigger cell here. So now I want to find out that now I put an equal sign, t dot inv, and my probability is 0.025, and 6 is my degree of freedom. So that is my t value there for so now this is the equation that we'll be using. So now we want to find out the confidence limits. So confidence interval here, confidence interval. So confidence interval equation is So let me copy it down from there. So this is our t value here. So we need to find out the absolute value of the t as well. So rather I will make another line here for your clarification. So absolute value of the t is ABS of absolute value of the t value that we got from there, which is 2.445. So now the confidence interval will be really the two confidence interval, one is the lower and the upper. So if we say this is lower, and then we say upper, so it will be average minus absolute value of t times standard deviation. So what is our average value? Average value is here 10 minus absolute value of t is here times standard error. Standard error is here. So that is the lower limit. Confidence interval lower limit is this, and upper limit would be same equation, but as we have to use plus. Okay. Probably this is for the confidence interval lower. Otherwise, there will be confusion again. So I put it lower here. And similarly, we can write confidence interval UPPR upper is basically this equation, but we have to put a plus sign there. So in this equation here, we put a plus sign there for the upper confidence interval plus. Okay, so confidence interval lower, I think I should have put the number here because that is, we are putting the answer there. So average is here. And then minus absolute value of t is here times our standard error is here. And what is our upper limit? Upper limit will be same thing. So which is your average here plus absolute t times standard error. So that's the upper limit. So this is basically our answer. So this is the final answer here. So we'll put everything on the, I think we don't need this part because we have done it there. So I always like to put a boundary there so that when you're copying into the Word file, so this is the thing here. So this is the confidence interval of the mean. So the sample estimate of the mean was 10. So the 95% confidence interval of the mean is 9.73 to 10.26. So that means that if we take lot of samples from that kind of data from the population, then 95% of the time the mean value will be within this range. Any question on this? Do you have any queries or any? If you don't understand anything, please let me know.
Can you repeat that, sir? What's the CI lower and upper? What do they do?
What do they mean? Like you say, it's a point estimate average 10. Is that right? You can see that the average value is the 10. Is that right?
Yes, sir.
That is the point estimate. When I have the population, mean that I have the full data set. But here I have only 7 water samples, and I have measured the contaminant there in that sample. Ion, I have measured ion in that sample, only 7 samples, but I could have taken many samples from the river. And with the 7 samples, really I don't get a very good representative, because the water quality in the river changes with time. And I can take hundreds and thousands of samples. And the bigger number of samples I take, I'll get more accurate answer, is that right? And I'll get more accurate average value of the ion. But since I have taken only 7 samples, so it means that there is a lot of sampling variability in the mean that I am estimating. So that's why I'm trying to give a tolerance limit or error limit to my estimation of 10. So I'm giving a 95% confidence interval of the mean by this way, the 9.73 to 10.26. Is that clear now?
And sir, what we are understanding about that 95%, that if we pick any sample from the river, that will give us these deadlines that you just said a little bit earlier.
Or it's something like that. If I take a sample, then it's a 95% chance that the sample mean will be within that range. Not one sample, if you take a couple of samples, because you're dealing with mean, not one sample. If you take 8 samples or 12 samples or 13 samples, then, or 7 samples another time, then it is expected that 95% chance that your sample will contain within this range.
Okay, sir. Yeah.
The mean of those 7 samples, so you are taking another time, for example.
Can we say in either way, like from a population, if we draw 100 times sample, like 7 samples 100 times, so that 95 times value will be within this range.
That I mentioned first time. Yeah. So, so in another case, that if I take 100 samples from the river 100 times, and each sample has 7 values. So, and if I take the 100 mean, then 95 of those mean will fall in this range.
Okay, sir. Yep.
All right. So how do you like present the answer?
Sorry?
Like in the question, it asks to find the interval, right? Confidence level interval. So how do you present the answer?
Answer, I think that's a very good question. The answer we generally present like the mean value, we present the answer in this way. You can write in this way, that's fine. But generally in standard way, writing is that like your 10 plus minus or the best way is to write 9.7384, and then you write this sign here, and then you put your mean value here 10, and then you put another sign here. And that is your 10.26 on 59 or on 5. So you write here 95% confidence interval. Of the mean, I have to say 95% of mean. So you can write the answer in that way as well.
Thanks, sir.
Okay, so that's the one question. So I'll go to the another question. Say I'll go to question 4. So I'll upload the solution so that I think it will be easier to see. I think the way I have solved it now, I think is easy to follow. Is that right?
Looks good.
So I'll put this solution in the views as a solution so that if you follow that, because I have written the equation here as well, so that you don't, so you can see clearly. So during exam time, what you do if you solve in this way, and then you copy this part basically. And if you say Control C and then go to your Word document and paste it as a picture, or you snipe it and then put it there. Even I don't bother to put snipe. I can say Control C or copy it and then put in the Word and paste it as a special, as a picture there. It will be there automatically. Should I do it? Or everybody knows it how to do it?
Sir, sir, can you make please the row column D a little bit wider? I can't see the confidence level in bracket 95.
So let me see. So you cannot see the screen better.
The column D, column D.
Column D. I don't have, you mean this column here?
Yes, sir. Little bit wider.
No, I am not using this column. Like I am, the solution is here. The solution is basically the solution of this problem is here.
Okay, sir.
Okay. So what I am asking is that if you want to take it to Excel, like in your Word document during an exam time, just you copy it, I say press Control C. And now I am going to your Word document just to show you how I do it generally. So this is my Word file. Can you see the blank Word file here? And I say my question 3. So my question 3, and then I want to put the solution here. So I go to paste here, and then I go to paste special, and I put it as a picture enhanced meta file. So you see everything is here, is that right? So can you see my Word file?
Yes.
So you see that my question 3, everything is here when I insert that as a picture. So then I can make it PDF. Say I say file, save as.
Print maybe.
No, PDF. No, not print. Save as PDF. So I just you see file save as here when it comes the screen. Probably you cannot see the screen. When you go to the Word, then you can save any Word file as a PDF file if you go to save as. I think you don't know it, is most of the students.
Sir, I do print as PDF.
Yeah, but you can directly save it as PDF. Save as in the save as option. There are many options that you can save it as PDF file. Okay. Okay. Okay, now I want to solve question 4. Okay, so in question 4, it's telling that the following are the concentrations of manganese in 10 water samples. The value is given, find 95% confidence interval for the variances of all such samples of water. Assume a chi-square distribution. So in this case, we have to use a chi-square distribution. So the samples are given here. So these are my data here, sample data. So we'll find average. So average of the data, which is equation is V or average of or B3 to B12. So I am finding the average of these values quickly. And then we have to find the variance. So if you want to find out the variance, probably I better use capital R here, variance. So variance equation is VAR. So there are two variants here. One is the variance dot S and variance dot population. They will give the both answer, but it's better to use var dot S. So and then take the number. So this is the VAR dot S, and then we B3 to B12. So in Excel, there are two variant of the functions. Some of them, they indicate S means the sample. So when we deal with the sample, like in this case, we can use the variance dot S. But in many cases, they give the same answer because they assume the population sample is same. So you see variance dot S, and then this is the range. So that I have written here so that you know what variable I am using there. So variance is there. Then degree of freedom. By the way, degree of freedom is written by F in statistics in this kind of subject. So degree of freedom is basically n minus 1. If you want to find the n minus 1, then we need to find out the sample size, which is count n. And the function is count and the range of the data B3 to B12. So count these values. So degree of freedom will be count minus 1, n minus 1. So degree of freedom, we found degree of freedom. So we have to find out the 95% confidence interval for the variance. So we found a variance here that is 0.286222, something like that. So we have to find the 95% confidence interval of this variance. Okay. So to find the variance, we have to use a chi-square distribution. So the function we'll be using okay, so I will copy this text. So let me save my typing. Okay, so let us put row boundary here. So we have to do chi-square lower limit and chi-square upper limit. So in this case, we want to find out 95% confidence interval. So that means that we have to have 0.025 on the left and on the, so we are really dealing with two limits. So lower limit will be CHISQ chi-square dot INV .025 degree of freedom. And chi-square upper limit will be 975. Because we see that the difference between 0.975 and 0.025 is 0.95.
So how'd you get the bottom limit again? 0.02.
I think this one is the other way. Like when we are finding the confidence interval, then really it's 95%. So like in 0.025 is remaining on the right side of the distribution. So so it will be like we are really interested in between this interval 0.025 to 0.975. That the difference between these two is 0.95, which is 95%. So let us find this value. CHISQ chi-squared inverse, which is this one here. And then we have to write the probability 0.975, and our degree of freedom is here 9. And then if we want to put the another one, side square, inverse, and the probability is 0.025 times degree of freedom. Sorry, I think that has degree of freedom. We have to write the value, not the degree of freedom. This is 9. So I think we're dealing with the right value, 19. Okay, so that's the lower limit and upper limit that we have found. So we can find the confidence interval now. So variance and lower limit we have to find in this way, that the degree of freedom times variance divided by chi-square upper limit. So variance lower limit, lower confidence interval of variance. So I have given the equation at the bottom, which is the degree of freedom. Degree of freedom is 9. And then variance is, this is the value of the variance, and divided by the chi-square upper limit, which is this one here. And the upper CI of variance is degree of freedom, which is 9 times or value of the variance there, divided by chi-square lower limit here. This chi-square upper limit, so there's the calculation mistake here. So this will be
Hey, sir, I'm sorry to interrupt. I have to head off to work now. I was wondering if I could get my name
can you
marked.
take the attendance, Saika? Can you take the attendance, please?
Yeah, Prof, I can take now. For
Thank you, sir.
everybody's attendance or only for Oliver?
You can start taking attendance here.
Yeah, Prof. Hello, everyone. Good afternoon. I'm just now taking your attendance. Please be attentive. Ali Muhammad.
Yeah, I'm here, Miss.
Thank you. Daniel Al-Saifi. Daniel Al-Saifi. Okay. Ahmed Sharmad Alawit. Ahmed Sharmad Alawit. Ayman Al-Zahraini.
Yes, Dr. I'm here.
Thank you. Amod Srestha.
Yes, I'm here.
Thank you. Asifullah.
Present.
Thank you. Bayud. Hanan Sharmad Bayud. Okay. Then Alexander Baker.
Yep, I'm here.
Thank you. Bestrin.
Yeah, Miss.
Thank you. Alex Brook.
Yep, I'm here.
Thank you. John Karim Koim.
Yep, here.
Thank you. James Carpenter.
I'm here, Miss.
Thank you. Salah Darwis. Salah Darwis. Salah Darwis. Okay. Yuki Deshe.
Yeah.
Narus Dungana.
Yes, Miss.
Suleiman Faisal. Suleiman Faisal. Hanifa Gardishtani.
Yes.
Thank you. Bikal Gimeri. Bikal Gimeri. Lusland Vincent Gibbons. Lusland Vincent Gibbons. Prof.
Yeah.
Lusland and the Salah Darwis. They're all present when I was giving marks.
That's all right. You can keep them present then. Yeah.
Okay.
Miss. Excuse me, Miss.
Yep.
Miss, my name, I couldn't say my name. Present.
What is your name? Can you please say?
Rodrigo Valvitege.
Oh, it's okay.
Thanks, Miss. Bye.
Okay.
Miss, did you call my name?
No, I will continue then. Gursavijit Singh.
Okay.
Yes, miss, I'm here.
Okay, thank you. Hashim Hassan. Hashim Hassan. Then Daniel Aggie.
I'm here.
Thank you. Sabiha Jamshed.
Yes, I'm here.
Benjamin Kahane. Benjamin Kahane.
Yeah, I'm here.
Thank you. Azim Khan. Azim Khan. Grishmi Kanal.
Yes, ma'am, I'm here.
Thank you. Then Manali Kirodia.
Yes, miss.
Thank you. Agatha Gosinska.
Here, miss.
Thank you. Lalinda Kukule.
I'm here, miss.
Thank you. Jufen Luo. Jufen Luo.
Oh, yes, miss.
Thank you. Prithviraj Motra. Prithviraj Motra. Prithviraj Motra.
Present, miss.
Thank you. Arun McAllister.
Yep, I'm here.
Thank you. Ayush Mishra.
Present.
Thank you. Abanab Nasrallah. Abanab Nasrallah. Abanab Nasrallah. Neil Rakesh Patel.
Present, me.
Okay, thank you. Rohan Pearson Bourne.
Present.
Thank you. Austin Paris.
Yeah, I'm here.
Thank you. Anushua Pirapithan. Anushua Pirapithan.
Yes, miss, I'm here.
Thank you.
Yes, miss, I'm here.
All right. Moshe Tanjim Rahman.
Ah, yes, I'm here.
Thank you. Muhammad Ali Raja.
Present.
Thank you. Yusuf Hisham Rifat.
Yes, I'm here.
Okay, thank you.
Oh, thanks.
Rodrigo just present. Rodriguez, Jacob Rodriguez. Jacob Rodriguez. Okay. Brandon Rosas.
Yep,
Thank you.
present.
Oji Sadi. Oji Sadi. Okay. Muhammad Sadiq.
Yeah, I'm here.
Thank you. Sabita Shahi Mahal.
Yeah, present, miss.
Thank you. Abhinav Sreshta. Abhinav Sreshta. Pranil Van Singh.
Here.
Thank you. Mutasim Tai. I think he's present. And then Naurus Tamena. Naurus Tamena. Absent. Minnahat Khan. Minnahat Khan.
I'm in the train. I'm here.
Okay, thank you. Young Ong,
I'm here.
thank you. Young Jang,
Yes, miss.
thank you. Then Tamara Kohlia. Tamara Kohlia. Tamara Kohlia. Okay. Ali Hamad,
Yes, Miss. Ali Ahmed here.
Nilufa
Yes,
Frame,
ma'am, I'm here. Thank you.
thank you. Abu Huraira. Abu Huraira. Orpita,
Present, ma'am.
thank you. Amir. Amir. Okay. Priti.
Yes, miss.
Okay, thank you. That's all. Thank you, guys.
Miss,
Sorry, did you take my attendance? or
What is your name? Can you please?
Salah Dawich?
Salah Darwin.
Yep.
No, I already present, make you present because I remember.
Okay, so I think today we have already finished our time. So this question, basically we are trying to find out the confidence interval of the variance. In previous problem, we found the confidence interval of mean. And to find the confidence interval of mean or average,